So dear students, now let me discuss some more problems on gradient of the scalar function. Okay, so the problem is that one of the point at which the derivative of the function f is equal to x square minus xy minus y plus y square vanishes along the direction I cap plus root 3 j cap divided by 2 each. So what you have to do, you have to check for which point of x and y. You have to find out the points, that is x comma y, such that the directional derivatives of this function along this direction is 0. So let me first find out the directional derivative, and for that case you have to find out first gradient of f. So f is here given, which is x square minus xy minus y plus y square. Okay, so you will have gradient of f. So the first component will be del f del x. For del f del x you will get 2x from here, y from here, minus y. Okay, and these are 0. Okay, so when you talk about del f del x, then you will have to find that terms which involve x. Okay, so here involve x, so it will be 2x, and here involve x, so differentiation of x is 1, so it will be only minus 1. So this will be the I cap. This will be the I cap. Now you have to find out del f del y. So for del f del y you will get 2y from here. So 2y and minus 1 from here, and from here you will get minus x. That will be j cap. Okay, and there is no k cap because it's function of x and y only. So this will be our gradient of f. Now we have to take the dot product of gradient of f with this unit vector. Okay, so directional derivative you can say. So directional derivative will be, directional derivative is equal to, so this 2x minus y I cap plus 2y minus 1 minus x j cap dot I cap plus root 3 j cap divided by 2. So what it will give you? It will give you just 2x minus y and I dot I, that is 1. So it will be half into 2x minus y, and plus for this case you will get root 3 by 2 into 2y minus 1 minus x. So let me write it again. So it will be 2 will be cancelled out, so it will be x minus y by 2. Let me open this. Okay, plus here 2 will be cancelled out, so it will be root 3y minus root 3 by 2 obviously, and minus root 3 by 2x, Now let me take x and y separately. So if you take common x, you will get 1 minus root 3 by 2. Okay, so if you take x common, you will get 1 minus root 3 by 2. That means you can write it as 2 minus root 3 by 2. Okay, so 2 minus root 3 by 2, this will be. And if you take y, then it will be what? If you take y common, then it will be root 3 minus half. Okay, root 3 minus half, that means 2 root 3 minus 1, and obviously there will be minus root 3. Obviously there will be minus root 3 by 2 into x. Okay, and you have to prove, you have to find the for which point of x and y, this is not x, only root 3 by 2, this point of. So you have to check that for which point of x and y this will vanish, this will be 0. So you have to just check. So you have to just put these points a, b and c, d. So you have to check the option one by one. Let me check the option b. Okay, this will be correct answer actually, and I am giving you the process of checking. Okay, so you have to find out here. You have to put first x is equal to minus 1 here. So when you put x is equal to minus 1 here, you will get just minus 2 minus root 3 by 2 plus, for y you have to put this 2y. So plus for y you have to put 2y 2 root 3 minus 1 minus 1, and here what you will get 2 root 3 minus 1, you will get 2 root 3 minus 1 divided by 2 and minus you will get root 3 by 2, you will get root 3 by 2. So what you will have, you have just, you can see from here, you have just this 2 will be cancelled out, and this will, so this term will be 1. Okay, this term will be 1, this will be cancelled out, so it will be what, minus 2 by 2, that means minus 1. Okay, and minus root 3 by 2 that will be plus root 3 by 2, and from here you will get plus 1, and here you will have minus root 3 by 2, and that will give you 0. So this will be the correct answer. Actually for this kinds of problem, what you have to do, you have to check for each and every option. Okay, so which option will be match, you have to find out. Okay, so this is the problem and you can do it easily. Okay, so let's move to the next question also. So now here the question is that which of the following is a unit normal vector to the surface z is equal to xy at p is equal to 2 comma minus 1 comma minus 1. Okay, which of the following is a unit vector normal to this surface? So let me give you a solution. So here xy is equal to z is given, or you can write it z is equal to xy is given. So you have to take the function like this, f is equal to z minus xy, and then you have to find out the gradient of f. Okay, so what will be the gradient of f here? So first you have to differentiation with respect to x. So when you take del f del x, it will be just minus y, so it will be minus y I cap, and for del f del y it will be minus x, so minus x j cap, and for del f del z it will be 1, so just k cap. Now if you want to find out this gradient of f at the point 2 comma minus 1 comma minus 1, then you can do it, and if you put the value instead of y, it will be minus 1, so that will be I cap, and for x you have to put 2, so it will be minus 2 j cap plus k cap plus k cap. Okay, so the unit vector will be gradient of f at that point divided by mod gradient of f, so you will get this I cap minus 2 j cap plus k cap divided by root 4 plus 1 plus 1, that is root 6. So this will be the correct answer. Okay, so this is a very easy problem. Next, move to the next question. Okay, so here f of xy is given ln root x plus y, and g of xy is also given root x plus y. Then you have to find out the value of del square fg at 1 comma 0. So what will be fg? First let me find out fg. Okay, so f is given and g is also given, so fg can be written as root x plus y into ln root x plus y. Okay, so this is fg. So del square fg means del square fj. What is meaning of del square fj? That will be nothing but del 2 del x2 plus del 2 del y2 is the Laplacian operator. It will operate with fg. That means you have to find out del 2 fg del x2 plus del 2 fg del y2. So let me find one by one. So first we have to find out del x fg. Okay, first differentiation. So what will be the first time differentiation of this? So let me, this function is unchanged, u into v derivative. Okay, and derivative of log ln x, that will be 1 by root x plus y into differentiation of this root x plus y is 1 by 2 root x, that means 1 by 2 root x plus y into 1. Okay, plus if you take ln root x plus y constant, ln root x plus y constant, then what you will get? You will get differentiation of this root x plus 1 is 1 upon 2 root x, 1 upon 2 root x plus y. So now this will be cancelled out, and it will be just 1 by 2 root x plus y plus 1 by 2 root x plus y into ln root x plus y. This is del x fg actually. Now you have to take differentiation again with respect to x. So it will be now del 2 del x2 fg. Okay. So now what you have to do, this is x plus y to the power minus half. So it will be minus half. So it will be half there is there, and it will be minus half into x plus y to the power minus 3 by 2 plus, let me unchange this part, 1 by 2 root x plus y, and again differentiation of this is 1 by root x plus y, and differentiation of root x plus y is 1 by 2 root x plus y, plus, let me unchange this ln of root x plus y into, we have to differentiate this function again, and it will be just half into same, half into minus half into x plus y to the power minus 3 by 2. Now let me arrange this thing. So it will be minus 3 by 4 x plus y to the power minus 3 by 2, and what this will be also 1 by 4 actually, 1 by 2 into 1 by 2, and that is also 1 by 4, not 3 by 4, 1 by 2 into minus 1 by 2, and that will be also plus 1 by 4 into root x plus y root x plus y root x plus y, that means x plus y to the power minus 3 by 2, and plus it will be just, it will also be minus 1 by 4 x plus y to the power minus 3 by 2 into ln root x plus y. So this term will be cancelled out, and the only survivable term will be this. But you have a point 1 comma 0, so if you put for x is equal to 1, so what will happen, and y is equal to 0. So if you put here 0, y is equal to 0, and x is equal to 1, then it will be ln 1, and ln 1 will be always 0. So this term will be vanishes. Okay. So del 2 del x2 is equal to 0. Similarly, you will get this term will also be 0, because the function is symmetric function. If you change x in place of y, nothing will be changed. X plus y ln root x plus y is the same as y plus x root ln root y plus x. So the differentiation will be same, because it's a partial differentiation. It does not matter how you will differentiation with respect to x or differentiation with respect to y, it will give you the same result, same expression you will get, exactly same expression you will get. And when you will put this 1 comma 0, you will get 0. Okay, so this B will be correct answer here. Okay, so next question, and here the question is that the spheres x square plus y square plus z square is equal to 1 and x square plus y minus root 3 whole square plus z square is equal to 4 intersect at an angle. So what will be the intersecting angle between these two spheres? So let me first find out the point at which these two spheres will interact or may interact. There will be several number of points, but let me find out one of the point at which we have to find out the angle. So here one sphere is given as x square plus y square plus z square is equal to 1, and another sphere is given as this. So let me open this bracket. So x square plus it will be y square minus 2y root 3 plus 3 plus z square is equal to 4, and if you put this x square plus y square plus z square is equal to 1, then that will be 3 plus 1 will be 4, and this 4 and 4 will be cancelled out, so it will be minus 2y root 3 is equal to 4. 0 is equal actually. So y is equal to 0 is 1 point. Okay, and you can choose. So you can choose from here that y is equal to 0. If you choose x is equal to 0 and z is equal to 1, then this equation will satisfy. So you can take one of the point of intersecting point is 0, 0, 1. This is one of the intersecting point. Now you have to find out the angle actually the unit vector for this sphere and this sphere. Okay, so how you can find out the unit normal vector for this surface? So you have to find out the gradient of f at this point. So let me suppose this is f1. So f1 is equal to nothing but x square plus y square plus z square, which implies that gradient of f1 is equal to 2x I cap plus 2y j cap plus 2z k cap. Now if you put 0 comma 0 comma 1, it will be just 2 k cap. So the unit vector will be n cap, will be just k cap, just k cap, n1 cap you can say. Similarly, if you find out for f2, so if for f2 you have this, actually x square plus this 4 and 4 will be cancelled out, so it will be modified form will be x square plus y square plus z square minus 2y root 3 and is equal to 1, will be 4 minus 3, that will be 1 actually. Okay, and if you take gradient of f2 here, so what you will get? You will get similarly 2x I cap, but for del f del y you will get 2y minus 2 root 3. You will get 2y minus 2 root 3 j cap actually or for k cap it will be again 2z k cap. Now if you put the point here also, so this will be 0 and this will be just minus 2 root 3 j cap for y is equal to 0 and for k is equal to, it will be 2 k cap, for z is equal to 1. So what will be the n2 cap? So n2 cap will be now this unit vector minus 2 root 3 plus 2 k cap divided by, that will be square root of this 4 into 3 12, 12 plus 4 16, that will be 4. So it will be just, if we divide by this 2 you will have, and that will be j cap obviously. So you will have minus root 3 j cap plus k cap upon 2. So this is n1 cap and this is n2 cap. Now how you can find out the angle between these two direction? So you have to take the dot product. So n1 cap dot n2 cap will be, so dot product will be n1 and n2, so only k cap is here, so k cap is 1 and here coefficient is 1, and 1 into half it will be half, and for this coefficient it will be 0, so the dot product will be half only. And you know n1 dot n2 is nothing but cos theta, because this is the unit vector, so 1 into 1 into cos theta. So cos theta is equal to half, means theta will be pi by 6 or pi by 3. Cos theta is equal to half, that means cos theta is equal to half means what? I think it will be cos pi by 3, okay, not pi by 6, it will be pi by 3. So this D will be correct answer. Okay, so let's move to next question also. So you can find out another problem. Okay, another problem. So here the plane are given, two plane are given. One is x minus y plus z is equal to 0 and 2x minus z is equal to 4. And you have to find out the angle between this plane. Concept is same. And you have to take f1 as x minus y plus z, and you have to take f2 as 2x minus z. Now if you take here gradient of f1, it will be I cap del f1 del x, that will be I cap, minus it will be j cap plus k cap, and from here you will get gradient of f2 will be what? 2I cap minus k cap. So from here you will get n1 cap is equal to I cap minus j cap plus k cap divided by root 3, the unit vector, and for here you will get n2 cap, that is equal to 2I cap minus k cap divided by root 5. And now if you take the dot product between these two vector, that is cos theta, and that will be the dot product, and this I dot I is equal to 1, and this k dot k, this k dot k is also 1, so it will be 2 and j with j it will be 0, so k dot k will be 1, so it will be 2 minus 1 divided by the coefficient root 3 into root 5, it will be root 15, so it will be 1 by root 15. So from here you can find that cos theta is equal to 1 by root 15, and that means theta is equal to cos inverse 1 by root 15. 1 by root 15. Okay, so this will be the answer. This will be the answer. Okay, so now let's move to next question. So here what is given? And the function f is given. Suppose the directional derivative of f in the direction of unit vector u1 u2. u1 comma u2 is the unit vector here given at the point 1 comma minus 1. So here n cap is actually given as unit vector is given as u1 comma u2, that means u1 I cap plus u2 j cap, and the f is given also. F is nothing but x y square plus y x square. So you have to find out gradient of f. So what will be gradient of f? Gradient of f, when you talk about del f del x, so it will be y square. For the first term it will be y square, and from the second term it will be 2x. So y square plus 2xy, 2xy I cap plus for j cap you have del f del y. So from here you will have 2xy, and from here you will get only x square into j cap. Now what are the point? Point is 1 comma minus 1. So x is equal to 1 and y is equal to minus 1. So that means y is equal to minus 1 means here 1, and x is equal to minus 1 means minus 2. Similarly here 2 into xy, that means minus 2, and x square means 1 j cap. So it will be minus I cap minus j cap, minus I cap minus j cap. Now if you take the directional derivative, then that will be what? Gradient of f dot n cap, and gradient of f is minus I cap minus j cap, and we have to take dot product with this, and the n cap is given u1 I cap plus u2 j cap, and that will be 1. For which value of u1 u2? That will be 1. Directional derivative is 1. So it will be minus u1 minus u2 is equal to 1. Now you have to check for which set of value this will satisfy, and you can easily find out that this value will be satisfied, because when u1 is equal to minus 1, we will have this 1 and this is 0, so left hand side will be right hand side. So this will be the correct answer. Okay, you have to check always for this kinds of problem. Okay, so next question. Here what is the question? We have to find out the value of a and b. For what values of a and b, the directional derivative of u, that is given by ax square yz plus bxy square z at 1 comma 1 comma 1 along this vector is root 6, and along this vector is root 3 root 6. So two directional derivative, the magnitude of two directional derivative are given. So and two vectors are also given. One is I plus j minus 2, another is I minus j plus 2. Okay, so what you have to do, you have to take the dot product with the gradient of u. So first you have to find out gradient of u. So what will be gradient of u? So with respect to x, so you will have 2ax yz plus, from here you will get by square z I cap plus, for del f del y you will get ax square z, and from here you will get 2b x yz into j cap plus, for del f del z you will get ax square y plus bxy square into k cap. So this is the gradient of u. Now let me put 1 comma 1 comma 1. So it will be 2a plus b I cap plus, it will be a plus 2b j cap plus, it will be just a plus b k cap. Okay, so 2a plus b, a plus 2b, and a plus b k cap. So this is gradient of u. Now for the first case, for the first case. You have to take the dot product with this vector. So gradient of u dot I cap plus j cap minus 2k cap. And what is this? So dot product with I cap, that is 2a plus b, and dot product with j cap, that will be a plus 2b, simple. And dot product of a plus b with this, there is a minus 2a minus 2b. So we will have this 2a will cancel out, this will be cancelled out, so it will be just a plus b, and this value is given here according to the problem is root 6. So it will be root 6. So you will have one equation, that is a plus b equal to root 6. And you can get another equation also by making the dot product of gradient of u with this vector I minus j plus 2k, I minus j plus 2k. So little change will be there. So here this will be same 2a plus b, but here we will have minus sign, so it will be minus a minus 2b, but here plus sign, so it will be plus 2a plus 2b. So only this will cancel out. So 2a plus 2a, 4a minus a 3a, so it will be 3a plus b. So 3a plus b, so that will be 3a plus b, and that is given as 3 root 6. 3 root 6, but one mistake is there because we do not find the unit vector. So for unit vector it will be divided by root 6, because the magnitude of this vector is root 6. So one root 6 will be here. So root 6 it will be 6. It will be 6, and it will be 3 into 6, that will be 18. So we have two equations. One is 3a plus b is equal to 18, and another is a plus b is equal to 6. So if you subtract, you will get 2a is equal to 12, that means a is equal to 6. So when a is equal to 6, so obviously b will be 0.